Hey everyone, it's Matt here. Welcome back to another episode of Savant's Tech Talk. A weak design strategy can be a mess for software engineers. One of the most annoying things for any professional is editing or rewriting a code after being done with it. Sometimes it's difficult to add a modern feature to their applications because it's complex, and other times you have to edit, rewrite, or add to the pre-existing code to make it more mobile friendly and testable. When creating a design for any system, having certain principles as guidelines can be helpful. They can highlight the points that you need to remember and what you need to steer clear from. Now, they're certainly not rules, and you don't have to follow them all the time. However, using them as a criterion can help you develop a code that needs less editing later on. Are you interested to know what these principles might be? Then keep watching. And don't forget to hit that like button and subscribe to this channel for more videos. Also, are you a software engineer? If so, let us know how long you've been one, or if you're just starting out. Now let's jump into it. The first principle is to break it down. The philosophy divide and conquer works even when related to software engineering and system designing. When you break down a problem into subproblems, you reduce its complexity. This way it's easier to deal with the smaller issues one at a time. Similarly, when you design a system with several subsystems in it, focus on each subsystem individually. If they have issues, resolve them one by one. This way the entire system will be broken down into smaller parts, and your whole designing process will break into smaller milestones. Keep the design cohesive. So cohesion refers to merging similar things and putting them together. So for example, when you organize your room, putting all of your clothing items in your wardrobe and your shoes in the shoe rack is a more cohesive approach. So when you're looking for anything that's wardrobe related, then you can find it in the wardrobe. If you're looking for, say, socks and sandals, then you can find them in the shoe rack. Anything that's connected together can be found in the same place. Similarly, when developing a system, you can bring together classes, models, and packages and design them cohesively. And doing this will improve your code's organization. And the result will be a much simpler system where things will be easier to locate. Your entire system will make sense as a big project and when you break it down into smaller parts. Reduce interdependence. In software terms, the word coupling refers to interdependent files, classes, models, and packages. While many software engineers think that this approach is great, others highly disagree. And the logic is that if all the packages are dependent on each other, then you will have to edit all of them if one of them needs editing. The result will be an entire system being compromised because one part of it was dysfunctional. So I know it's easy to implement a coupled system to a new design, but when it comes to debugging and fixing it, it can become a big mess. And that's precisely why we advise engineers to keep components and parts of the system as independent from each other as possible. Focus on abstraction. Making your system abstract means simplifying it and generalizing your code. So to put it in simple words, a system that's not abstract would only identify specific colors that you put in the code. For example, if you enter red in the system, it will only identify red and no blues or greens. However, when you generalize the code, it means that the system will identify any colors presented to it. And in this way, abstraction minimizes the duplication in your code and increases security. Prioritize reusability. When a software engineer develops a code, it's essential that they think about the future and make sure that it's reusable. Abstraction and reusability are similar concepts that walk hand in hand. As I explained with abstraction, you should generalize the code instead of specifying a particular function in the system. This way it becomes usable in various ways instead of just one. If your system works with only the red color, then your input will be limited. Plus, what would you do if the client later needs different colors in their system? Your code will be more reusable if you generalize it and it accepts more colors. And you won't have to go back to it and rewrite or edit it when the user needs more options. It's already generalized and will serve future purposes just as it is. I just want to quickly say, if you're still with us, I think that deserves a click on that like button. Also, let us know if any of the principles that we've listed so far are helpful to you. Flexibility is non-negotiable. Flexibility in your system is an absolute must. The whole point of using these principles is to make sure your code is versatile and usable in the future. So when you're designing your code, make sure that you make it as flexible as possible so that later on, it can accommodate the upgraded needs of the user, instead of focusing on the design that suits their needs for today. Choose components that are better for both their present and their future needs. Keep obsolescence in mind. When you use external dependencies in the system or project, remember that certain dependencies can be completely obsolete in the near future. Once it's deprecated and the system is updated, it will most probably stop working. The best way to prevent a situation like this is by making sure you use reputable software, minimize external dependencies, and avoid poorly maintained and documented projects. Portability is a must. In today's day and age, programmers and software engineers should know that a particular system is very rarely used on one gadget or platform. Soon the system you're designing for a phone might be used on a laptop or a tablet as well. So let's say you create an application that can be used on the web only, then when users want it for their iPhones and Android phones, it will be very complicated to create a whole new system for them. And therefore, focusing on portability when you design the system in the first place can be very important. You can't forget testability. Most developers forget about testability when they're designing small projects. But when you work on larger systems and create larger code bases, then this particular thing becomes very important. Larger companies like Microsoft and Google run thousands of tests every day to ensure that everything works fine and no new submissions are causing any problems. So how do they do that? Well, it's simple. The developers were smart enough to make sure that such massive code bases were highly testable. And last but not least, a defensive design is important. Have you ever heard of the term proofing your codes? Well, it simply means that when you design a system, you need to keep in mind that the user is a beginner. So your notifications and error messages should be incredibly clear. As soon as someone messes around with the system, they should get an error message to tell them precisely what they are doing wrong. The invalid input should be handled appropriately, and the system should be powerful and secure. When you design a system defensively, beginner users can easily identify the mistake that they're making and find a solution for it. So there we have it. What do you think? Let us know in the comments if you found these principles to be helpful to you. Again, you don't have to design every system revolving around these principles. These are merely guidelines that will make sure whatever you create is more flexible, testable, and ideal for the long run. Depending on what kind of design you're going for and your client's needs, you can pick and choose the principles that apply to your situation. So a quick summary of the 10 principles are: break it down, keep the design cohesive, reduce interdependence, focus on abstraction, prioritize reusability, flexibility is non-negotiable, keep obsolescence in mind, portability is a must, don't forget testability, and a defensive design is important. Once again, if you enjoyed this video, don't forget to hit that like button and subscribe to this channel for more videos. Thank you for watching.